Hi, I'm Nima, and for my ICU, I made Flappy Bird, but I also made a system for an agent to teach itself how to play Flappy Bird. So what does that mean exactly, and how did I do that? So first of all, I want to talk about how neural networks work. So essentially, on a high level, what they do is given a series of inputs, so an input layer with structured data, so data that you know what like each variable means and how it's calculated, you can reliably get an output layer that can give you outputs that are best for the circumstances or input layer that is given. So what does that mean exactly? So a really good example of this is housing price prediction. So given a series of inputs like the house size, the number of bedrooms, the zip code, and your income level, you can get a fairly good estimate of what the price of the house will be given these inputs. But how is that calculated exactly? Well, in the case of housing prices, how it's calculated is that given these inputs, a hidden layer is calculated that can then calculate an output layer. This hidden layer is calculated by a series of weights. So each of these lines for each of these nodes is a series of weights that is multiplied by the input layer value and added up and summed up to get the hidden layer node value. And then the same thing happens to the output layer. So these weights basically dictate like what our numbers will look like in the end and what our final like output will be. So in the case of housing prices, it will just be the price of the house. And in the case of Flappy Bird, it will be if our bird should jump or not. And this input layer is basically the circumstances of the bird. Now, this works by using a lot of like linear algebra and matrix multiplication, and it also works by optimizing our weights to make sure that they give us the best possible results for whatever situation we're in. So how it works to get the best possible weights in the neural network is there's a lot of different strategies, and like one of the most like popular is like backpropagation. So for example, if you had housing price prediction, you have a bunch of data on like housing prices, and then you could work backwards from that data to get weights that are accurate and can predict the data. In the case of Flappy Bird, we don't have data on like a bunch of Flappy Bird games. But what we can do is we can run a bunch of Flappy Bird games. We can see how each bird performs based on its weights, and then from there we can pick which weights work the best within like a generation, and then create a new generation that has slightly mutated weights. And then we can over time find like our best bird or best result, and then like make that like our golden standard for weights, so that we have a good like approach for what our output should be. So I'm gonna jump into the code right now, and I'll jump right into the neural network and how that works. So essentially, we are given the matrix of weights from the input to the hidden layer, so this right here, and then the matrix of weights from the hidden layer to the output layer, so this right here. And we also have a bias layer, so that it adds a bit more variety. That's just what we add on top of that. And basically how that works is that given an input matrix, so this right here, we multiply that by our weights, we add it by a bias, and then we use an activation function. In this case, I'm using the sigmoid function. This just guarantees that our values are normalized. They're between like 0 and 1, and like they don't like lose like their significance or like meaning. And then we do the same thing to this hidden layer to the output layer. And in this case, for in this neural network right here, we have 2 nodes as the output layer, 3 as the input, and 4 as the hidden. But what I'm doing is I have 5 nodes for the input, 5 nodes for the hidden, and 2 nodes for the output. Those 5 input nodes represent the distance between the bird and the closest pipe, the y distance between the bird and the top of the pipe, the y distance between the bird and the bottom of the pipe, a bird in the bottom of the pipe, bird in the top of the pipe, the y position of the bird, and also the velocity of the bird. And I'm also normalizing these values by the gravity, the height of the game panel, the width of the game panel, stuff like that. And then the 2 output nodes are the probability of the bird to jump and the probability for the bird not to jump. And from there, we can decide whether or not we want our bird to jump. So on a very high level, that's how it works. And then I promise I'll show the game like very soon. And then when we're trying to find a new generation, so once all the birds in the generation are dead and we want to find a new generation, what we basically do is we find the best bird in the generation, and we already had a previous best bird, and we add that as well, just like that's what I thought we should do, and we mutate it just a bit, so the values and the weights are just like modified just a bit, and then we also mutate our generation best bird, and then we select a bird, and like we could just like select the best bird from the generation and like have a generation that's just that, but there's not much diversity. So instead, we randomly pick some birds from our generation, but their chances of like getting in is based on their fitness score. So this is the algorithm to do that, where you subtract the bird's fitness, and then if it from this random number, and if the random number goes down 0, then we just pick that bird. And the bird's fitness is basically just proportional to the score of the other birds. So like how far it gets. So like for every second the bird lasts, it gets like 1 score, and then if it passes pipe, it gets 100, and then we normalize the fitness. So yeah, that's how it works. And I'm gonna run it and show you a demo. Sorry. So to run it, you go to the game. Awesome. So we can play like normal Flappy Bird. So if you just want to do that and like not do anything crazy, you can play normal Flappy Bird. So like I die, I get reset, my score resets in the top left there. But what we can also do is we can train. So this is basically what's happening. I'm randomizing a bunch of different weights and getting a bunch of different birds. And right now they all suck. So I'm gonna speed it up a bit and wait until we find a bird. Oh, so as you can see, we found like one smart bird, and right now a lot of the generation is like trying to follow it as well. And it's pretty cool. So it's called a genetic algorithm because it's based on like Charles Darwin's survival of the fittest. So whatever bird can perform the best will survive in the next generation and will like pass down its like genes. So I think that's pretty cool. And oh wow. So like around like 1,000, 2,000, 3,000 generations in, you'll see like birds going like 4 to 5 pipes, and then like 8,000 generations is like 40 pipes and stuff like that. So yeah, and then I'm saving the best bird and serializing it, and then you can load it right here. So obviously this bird isn't amazing. We've only trained it for a bit, but it's trying its best. Cool. Okay. I just want to see past 1 pipe. Come on, just 1. Okay, doesn't look like it. But as you train your birds more and more, they'll get better and better. And yeah, it's just very satisfying to. Oh yeah, your progress is also like saved and persisted, so you can come back, train it, and then save it and load it again. But yeah, this is my ICU. It was really fun. I got to learn a lot about neural networks. This class right here was heavily based off of an existing neural network class. It had backpropagation, but I just used the fitness to do that. But yeah, machine learning is like really interesting, and yeah, I really enjoyed this project. maybe Miss Wong should teach a machine learning course on workflow. I'd be happy to write the curriculum for that. But yeah, cool.